Hi, my name is Amit Ghadge. I am Director Product Manager from Parallel Wireless. In this session, we will go over a brief overview of cloud native applications. In this session, what we will cover is basically what cloud native applications are, what benefits do they offer, why it is gaining popularity, and what are the key tenets of cloud native application. There is a lot to talk about this topic, and it will take hours and hours to talk about each and everything. But in this session, the intent is mainly to talk about cloud native application philosophy and the basic concepts associated with it. So let's start. To start with, let's start with the formal definition of cloud native applications. What is cloud native? Cloud native is an approach in software development that utilizes the cloud computing to build and run scalable applications in modern dynamic environments, such as public, private, and hybrid clouds. Cloud computing has become a norm now, and it is now necessary that software-based applications are developed to be hosted on cloud infrastructure that could be hosted on-prem, in operator's own data center, public cloud, or hybrid cloud. In addition, they take advantage of the capabilities offered by cloud infrastructure to deliver service in an efficient, seamless, and resilient way. Cloud native is not just about the technology change, but also mindset and culture change in the way the software is developed. Waterfall model was a norm before, whereas cloud native truly enables agile development. Virtualization and software-based solutions have become a norm now. Virtualization has evolved over time, especially in telecom networks. Network functions were purpose-built hardware-based functions. They have then evolved to NFV with VM-based infra, and of late they have evolved to CNFs with cloud-native applications, which are gaining prominence given the benefits associated with it. Cloud native based virtualization has been in use for several times by several big companies like Google, Netflix, and others. Some of these big tech giants have been even key contributors to open source community in terms of seeding the code for some of the very popular cloud native open source tools. Then let's look at a bit of a comparison between the traditional monolithic applications and the cloud native applications, right? Monolithic applications have been were designed mainly keeping in mind the purpose-built hardware environment, which later then got even carried forward to the NFV VM-based infrastructure as such, right? I mean, monolithic applications are more stateful, and though they're modular internally, they have tight coupling, and they have dependencies, tight dependencies between them as such, right? And due to this, the side effect is that the scaling up or down or upgrade, downgrade, or it becomes very difficult and not so efficient as such, right? In order to make them run on cloud platforms as well, there is a separate support and qualification needed for each and every cloud or stack that is needed to be run as such, right? So this is where there are certain challenges and complexities involved with monolithic applications, and that's where, in comparison to this cloud native applications, which are more stateless, easier to scale, and can be deployed anywhere, any cloud as such, right? So they contain mainly loosely coupled components called as microservices. We'll see more about microservices later, but microservices which are components which are independently deployable, scalable, and upgraded, downgraded independently as such, right? And cloud native applications are also efficient in terms of resource utilization, given the nature of the environment that they need to run, right? And in addition to this, they provide the benefit of or capability of build once and deploy anywhere. Like let's say you can deploy it on bare metals, on VMs, or private cloud, or public cloud, or hybrid cloud as such, right? So that's the inherent aspect that these cloud native applications are going to bring in, and which is what is the factor or the aspect that's going to play as an advantage in terms of having cloud native applications as such, right? Let's look at the benefits of cloud native applications. Benefits are there from application user perspective as well as the application developer perspective. From an application user perspective, it offers competitive advantage to them as it allows them to be more agile and innovative. Cloud native applications with CI/CD capability allows them to try out new features and validate them and iterate multiple times before launching it in a wider network as such. Once they have tried and tested it in a smaller portion of the network. This isn't that easy with monolithic applications, and they take a lot of time to do such kind of trial and iteration kind of a model. Cloud native applications offer flexibility in terms of being able to be deployed in any type of cloud infra, whether it is public or private or a hybrid kind of a cloud. They provide elasticity in order to scale the application as per the needs of the network, thus increasing the resource utilization and power consumption efficiency as such. Faster recovery of applications is also something which is inherent, given that the containers are lightweight and instantiating and running containers is faster than the VMs as such. With CI/CD and automation, all infra and logistical aspects like upgrade, downgrade, and new feature launch will get automated, helping the users to improve the productivity and focus on delivering the core business logic or delivering business value as such, right? Uh, from the application developer perspective, Cloud Native allows the developer to focus on application logic and delivering the value rather than worrying about the infra and the environment, given the capability of build once, deploy anywhere with cloud native applications. It provides infra abstraction, which is a huge value add. And in addition to that, the microservice decomposition also helps in reducing the application complexity and simplifies the dependencies between the microservices, which are then owned by different teams, thus improving the collaboration between the teams as such. Cloud native is a very loosely used term. Some people just consider container support as cloud native. Some others consider support for microservices as cloud native. But truly speaking, a cloud native application needs to have support for these four key tenets together. Support for microservices, containers, DevOps, and CI/CD. Support for all is needed in order to truly deliver the benefits and advantage we talked about earlier. Agile development talks about building software incrementally, ship the functionality incrementally, and get feedback and iterate again. Cloud native development truly enables this real goal of agile development in reality. Without this, there are challenges in executing agile in true sense. Each of these four tenets are intertwined and all together deliver and execute the benefits expected out of a cloud native applications. Let's look at each of these key tenets one by one in brief. Let's now look at microservice in brief. Microservices is a technique that arranges an application as a collection of loosely coupled services. Basically, an application is decomposed into several microservices components. They communicate with each other over a network in order to fulfill a goal. Microservice is a self-contained piece of business functionality with clear interfaces exposed for others to use its services that it offers. Microservices are autonomously deployed, independently deployable, decentralized, and built and released with automated processes. There is no standard way of decomposing any application, but there are microservices guidelines or characteristics defined by some of the experts like Martin Fowler's and others, which act as the guidelines for decomposition. Some of them are listed here on the slide. Things like highly maintainable and testable, loosely coupled components, independently deployable, organized around business capabilities, and owned by small teams. These are just some of the key ones, and there are many more. Let's look at containers in brief. A container image is a lightweight standalone executable package of a piece of software that includes everything that is needed to run it. It includes code, runtime, system tools, system libraries, and its environment. Containers offer both efficiency and speed compared with the standard VMs. Using operating system level virtualization, a single OS instance is dynamically divided into multiple containers, isolated containers, each with a unique writable file system and resource quota of its own. Container images are typically in MBs and start almost instantly. Container engine, like a Docker, is a lightweight layer that enables running containers. Whereas in comparison, VMs are an abstraction of physical hardware, turning a physical server into many servers. Hypervisor allows multiple VMs to be created on a physical server. Each VM then in turn then includes a full copy of a OS called as guest OS, one or more apps on it, necessary binaries and libraries, taking almost up to around several GBs of memory. Thus, VMs are heavy and slow to start and may take several minutes to start and maintain. Let's look at CICD. CICD is a set of practices for continuous integration and continuous delivery. Continuous integration basically is a practice of merging all the developers' working code to a shared mainline several times a day. Every merge is validated before merging to catch any issues. This is in order to ensure that there are lesser integration issues and allows members in a team to collaboratively work together to deliver high quality software rapidly. Continuous delivery and deployment is basically a practice in which teams produce software in short cycles, ensuring that the software can be reliably released at any time, which can then be deployed as well. Intent is to build, test, and release software rapidly and frequently. This helps to reduce the cost, time, and risk of delivering changes by allowing more incremental updates to applications in production. Let's look at DevOps. DevOps is a set of practices that combine software development and operations, which aims to shorten the system development lifecycle and provide continuous delivery with high software quality. It is intended to reduce the time between committing a change to a system and then the change being placed into normal production, while ensuring high quality. Several DevOps aspects came from the agile methodology as such. Traditionally, there is a separate development team and a separate operations team, both working in almost silos, right? Each having their own different environment and development or testing models. This leads to a lot of back and forth between them and thus leading to slowdown of the process. With the capability of build once, deploy anywhere of cloud native, it becomes easier to remove these silos and simplify the development and expedite the operations process as such. Given the popularity and interest in cloud native application development and a strong open source community, there are several innovative tools available to take care of different aspects of DevOps and CI/CD. Jenkins for CI/CD, Puppet Chef for config management, Git for repository, and so on, right? These tools help in expediting the cloud native application development and management. Cloud Native Computing Foundation, CNCF, is a Linux Foundation project that was founded in 2015 to help advance container technology and align tech industry around its evolution. Its main purpose is building sustainable ecosystems for cloud native software. Currently, CNCF is supported by over 450 members. There are several tools and aspects that I haven't touched on in this session to keep things simple. One aspect, though, I want to touch a bit on is the container management. Container management is the process of managing the creation, deployment, scaling, availability, and destruction of software containers. Kubernetes is one of the most popular container management tool, and it's something that you will hear a lot about while talking about containers or cloud native applications as such. Just to summarize in the end and conclude this session, virtualization and software-based solutions have become a norm and are the need of the hour. Cloud native is the current and the future of software-based applications and the way to develop, manage, and deploy applications. Cloud native applications come with several benefits in comparison to monolithic applications. Key benefits include competitive advantage, business aligned operations, flexibility, and developers focus on adding true value. With that, I come to the end of this session on brief overview on cloud native applications. This was basically a 101 on cloud native applications, and this is just the tip of iceberg. There are several details I have not talked about to keep things simple in this session. I hope this session was useful for you. Thank you for watching this session. If you found this information useful and helpful, please be sure to hit the like button and subscribe to our channel for more videos like this. You can also visit our website at parallelwireless.com for more information. Thank you and see you again soon.